Liquid simulations are fantastic. You can use them, of course, to render out liquids in a video or any number of purposes for liquid sims that are more traditional in VFX. But I actually find that one of my favorite things to do with them is to generate unique and interesting flowing forms. And they're really powerful. You can do crazy form building with them. And I really encourage you to experiment with them beyond the scope of this specific tutorial. But I'm going to show you a couple of ways to just jump straight into liquids. And the easiest way is actually to just, in this scene with this default cube, what you can do is just select the cube or any object you might have and go to Object, Quick Effects, and Quick Liquid. And this will, as you see, populate the scene with a simulation. Now, what it has done is it has created another box around your object, this original cube. And this box serves as the domain for the simulation. And this domain is where the only region in this whole space where things are being simulated. And immediately, it is also given the cube a material for a liquid and a number of other factors. But if you just hit play, you'll see that whoosh, it is simulating via particles a liquid in this box. So it is contained to the bounding box, whoosh, and it flows down, and then you'll see it turns into waves down here at the bottom. If we want to change any of the properties or start to adjust and visualize this, we need to go into the physics properties of the liquid domain box itself. If you go in to the cube's properties, you won't see very many options, and you'll just see some of the settings for what this cube is represented as, and in specific, it is being represented as a liquid geometry. But we don't really need that for now. What we do need, though, is the liquid domain's physics property settings. And this is where all of the magic is happening. And if you just take some time to kind of read the keywords, you'll be able to see what it's doing. But the main things to see here are the resolution divisions, which is represented by this little cube in the corner. And this is the resolution of the simulation. So if you increase this number, the cube will get smaller and the resolution will increase, but it means it will take longer to simulate and the simulation will be more complex. Timescale will allow you to do things like, if you reduce this below 1, it will put your simulation in slow motion. And the CFL number is a kind of max velocity cap. The number of time steps allows you to get higher resolution simulations by it will simulate a single frame multiple times in the attempt to get a more accurate simulation. So you can increase this number. It'll take longer to simulate, but it will be more physically accurate. Border collisions are exactly what they say they are. When I pressed play, you saw that the liquid kind of crashed into the walls and the ground, and that is the border collisions. So if I turn these off, if I turn off the bottom, for example, the liquid will shoot through the bottom. It won't stop, but it will disappear still at the bounds. It just will not collide with it and be splayed back upwards. You don't really need to mess too much with these until you get more advanced into the liquid simulations. The most useful one that we're going to look at beyond those original settings is the mesh option. And this turns your liquid into a mesh. And so if I turn off ghosted view and wireframe, you'll see now a preview, and you'll notice that even though this original object was a cube, this is not a perfect cube. It's definitely already somewhat liquefied. And here you can adjust the resolution on that, but we're not going to mess with that just yet. I can just go ahead and press play though, and you'll see what that's starting to look like. And I quite like the mesh option because I love the preview that it gives you of the liquid itself. And you can start to see exactly what that's doing, and voila, we've already got a landscape right there. So there's lots of amazing uses for this, as you can already see, I hope. And as the more complex you make this setup, and you might even take a look at various force setups that you could do, but the more complex you make this, I think the more interesting your results can become. So of course we can increase the resolution on this, etc. If you want to cache the simulation, there are some, if you want to reuse the simulation or save it for later, you have to cache it. So what I would encourage you to do, particularly for liquid simulations, is to pick a new folder location to save this at, and then you will want to switch this to all and hit bake, and it will contain all of the settings you've set into your simulation. But before we do that, I'm going to kind of I would say mix up the pot, and I'm going to do that by adding an additional force into the scene. So I'm going to add a turbulence force, and I'll turn on ghosted view so you can see it. It comes in as this kind of plus symbol, but I'm going to scoot it down just below the cube, and I am in its physics properties of the turbulence force going to increase its strength and give it a little bit of flow and scale. And now, if I hit play, you'll see that nothing has exactly happened. And that is because with the current settings, this force hasn't really been applied. And I'm going to make it much more obvious. I'm going to make it stronger. And I might actually, for this, I'm going to turn gravity off on the liquid domain. And to do that, I have clicked the liquid domain object, which is that bounding box around the whole set. And I'm going to go down into the field weights down here at the bottom. And the field weights are where I can start to adjust the impact of certain types of forces. And maybe I won't turn gravity totally off, but I'll turn it all the way down to, so gravity is only 0.1 as strong, 0.15 as strong. And to get all of these changes to apply to a liquid simulation, it can be a bit tricky, and you won't always know if it's going to work. It can be a bit finicky, but I find the best thing to do is to just change this resolution divisions up or down one step. And when it does that, it kind of recalculates a lot of these settings. So now if I hit play, where it has low gravity and the turbulence force, you can see it has radically shifted the outcome. And that already looks pretty nice. I'm just going to let it keep playing to see if it changes drastically or anything. That's pretty good too. Let's say we're happy with this. I mean, it is pretty interesting. Already you could maybe imagine this as a kind of game level or some kind of crazy maze or something. But what I'm going to do is I'm going to kind of lock this in as a geometry. And to do that, what I actually just need to do is go to Object, Apply, Visual Geometry to Mesh. And now the simulation has been removed from the scene. You see I've hit play, but nothing is changing. And I have actually locked this liquid domain in as this mesh. And now I can do my normal mesh operations on it. I can go into edit mode, and I'm going to select one face, press Control L to select all of the linked, Control I to invert, and now I'm just deleting off those excess pieces. I could remesh it. And that's kind of lowered the resolution a little bit, so I'm going to try to get it a little bit closer and smoother. That looks pretty good. Now I could sculpt it. Smoothing it out, turning it into something totally other. But yeah, I think that's one of the most fantastic uses of these liquid simulations. Now, interestingly, if you remember, I mentioned it created a material. So I'm going to really quickly just go through and set some render settings. So I'm going to put the background to black, change a light to a sun with a nice power of 10. And if I swap into cycles, I'll use my GPU. Now if I go to rendered view, you'll see that this material is a bit translucent. So actually, I'm going to take 1 second to add in a ground plane, like a photo studio backdrop for us, so I can see what's happening. So all I've done is created it, added a diffuse material, and made it appear white. And now, when we take a look, you'll see that this material that it has created is like a water or a glass material. But of course, you can make this anything you want, and I would encourage you to play around with it a bit. You'll see that the liquid domain material by default is actually really a glass BSDF, and you of course can change the color and all sorts of good stuff with that. That red was pretty striking. So I encourage you to play around with that, especially in conjunction with some of these other processes. But of course you can change this material to being anything you want, and if you want it to be very geometry focused, you of course could just make it a flat color or something else. So yeah, I think that's the quick and dirty version of the liquid simulations.